Hello students, welcome to my second Digital Learning Week video. I hope you're doing well. I hope you're having fun. I hope you're safe. There's a lot going on in the world, but I hope I can still provide you with some meaningful science. Well, let's get into it. Let's talk about why we have seasons or the reasons for the seasons. This is part of our overall study of the Earth-Moon-Sun relationship. And our standard is to analyze and interpret data to relate the tilt of the Earth to the distribution of sunlight throughout the year on seasons. Now that's just a fancy way of saying we're going to look at data to relate the tilt of the Earth to the amount of sunlight we receive throughout the year on seasons. Now we're not going to do that in this particular video, but in future lessons we will. Some key vocabulary before we get going is axis. The Earth sits at an angle, and if you've ever seen a globe, you know that the Earth is always sort of not straight up and down, but sort of at an angle, is at a slant. And we call that the Earth's axis, and I'm going to talk more about that in the next slides. You also have to know about hemispheres. The Earth is sort of divided into 4 hemispheres, but we're only going to talk about 2, which is the northern and southern hemispheres. The northern hemispheres includes like North America, Central America, Canada, which is part of North America, but we say China, we say that all of those places are part of the northern hemisphere. The southern hemisphere, we say, is places like South America, Australia. Those places we consider to be in the southern hemisphere. So anything below the equator, we say is southern hemisphere. Anything above or north of the equator, we say is the northern hemisphere. Last but not least, you kind of have to have some idea about a revolution, which is the Earth moving around the sun in a circle or in orbit. And we're going to talk more about that in the next slides. So back to rotation. The Earth rotates every single day. And it rotates from east to west every single day. And you can kind of see that in this picture. The side of the Earth that's facing the sun, that side is experiencing daytime. The side of the Earth not facing the sun, we say that side is experiencing nighttime. It takes the Earth 24 hours, actually about 23.5 ... hours, but it takes the Earth, we round up, it takes the Earth 24 hours to make one complete rotation on its axis. And so again, the side right here that is facing the sun, we say that side is daytime, and the side of the Earth that's not facing the sun, we say that that's nighttime. One important thing to sort of think about here is that the sun doesn't move, but the Earth is going to do all the moving. Next is revolution. And the term revolution means to travel in a circular path around another object. And so the Earth is going to revolve around the sun. Okay, it's going to revolve around the sun. And it takes the Earth 365 days to make one complete track or one complete circle or revolution around the sun. And you might have a better idea in terms of the moon. The moon also rotates around the Earth, and you can see that in this picture here. So the moon is going to go around the Earth, and it takes the moon about 29.5 days to go completely around the Earth. And so what you kind of got to think about is the Earth is going to revolve around the sun, and it takes the Earth 365 days or 1 year to go around the sun. And the moon is going to go around the Earth, but luckily for us, the moon only takes 29 days to go around the Earth. So again, it takes the Earth 365 days to go around the sun, and we call that a revolution. And it takes the moon only 29 days to go around the Earth, and we call that a lunar cycle. And we're going to talk about that, in future lessons. So as Earth is revolving around the sun, the northern and southern hemispheres are going to receive different amounts of sunlight. And because of that, they are going to experience different seasons. And so we're only going to focus on the northern hemispheres so that way you don't get too confused. But what you should know is whatever season the northern hemisphere is experiencing, the southern hemisphere is going to experience it the opposite. And kind of keep that in your mind. Whatever I say about the northern hemisphere, it is almost going to be opposite in the southern hemisphere. And so when the axis is tilted towards the sun as it's revolving around the sun, as if the axis is tilted towards the sun, it is known as summer for us. And typically we have longer periods of daylight. And when you think about it, in the summertime, it doesn't get dark until like 9:30, 10 o'clock. And that is because we're getting so much daylight and we are faced towards the sun. We're getting a whole bunch of daylight hours, and it's pretty much day for most of our day, if you kind of think about it that way. But it doesn't get dark until very, very late because that is when we are receiving the most amount of daylight. Now, when the northern hemisphere, when the axis is tilted away from the sun, we know that to be winter. And that is when we have the shorter periods of daylight. And when you think about it, in the wintertime, it gets dark around 4:30, 5 o'clock. It gets dark pretty soon. That is because during the wintertime, we are receiving a little bit of daylight hours. We're not receiving the same amount of sunlight we were before, and so our days are a lot shorter. So when I say daylight hours, I mean, you know, think about it as 24 hours is in a day. Okay, how much of that time is sunny? Okay, well, during the summertime, about 13, 14 of those hours are sunny, as opposed to in the wintertime, that number is a lot lower. We're looking at like 9, 10 hours are sunny compared to 11, 12. And so you kind of got to think about it that way. And so, as I was saying, as the earth is revolving around the sun, the northern and southern hemispheres are going to receive different amounts of sunlight. Now, when the northern hemisphere is experiencing summer, notice how the axis is pointed towards the sun, and we know that to be summertime. In the wintertime, on the opposite side, okay, the axis is pointed the bottom. If you look here, the southern hemisphere is pointed towards it. And so one of the ways I look at these problems, I always look for the axis or that imaginary line that people draw. That helps me figure out, okay, is it the northern hemisphere pointed towards the sun or away from the sun? And so for the northern hemisphere, I look for the North Pole. And if you look at it here, it's pointed towards the sun. And so I would say, okay, yeah, the northern hemisphere, North America, they would be experiencing summer. As opposed to if you look down here, okay, the southern hemisphere is pointed away and it's kind of dark. So I would say that they are experiencing winter. That's the opposite over here. If you look over here, now the axis on the North Pole is pointed away. And so in the northern hemisphere, we would know that to be winter because we're not getting the same amount and we're actually pointed away from the sun. And then in the middle is our spring and autumn, also known as fall. And we're going to talk about that here in a second. Where it's not pointed, if you look at the axis is not pointed towards or away. And so in that sense, we're going to talk more about that in the next slides. And so an equinox, this means equal. This is when we have equal day and equal night. That means we have about 12 hours of daytime, 12 hours of nighttime. They're about equal. The earth is not pointed towards or away from the sun, and we know that as spring and autumn. This is also called the vernal equinox or the spring equinox, and we're actually getting ready to have our spring equinox in March, March 21st. We should have our spring equinox, so that's coming up pretty soon. And then our autumn equinox, which is in September. And again, both of these examples, the earth is not pointing towards or away from the sun. It's equal day and equal night. And when I think about my favorite season, I think about fall. What's so great about fall is that it's not too hot, so we're not necessarily pointed towards the sun, and it's not too cold. It's not freezing. We're right in the middle, and as you look at this picture here, it's right in the middle. Not too cold, not too hot, and that's because we have equal day, so that's why it's not too hot, and equal night, so it's not too cold. We're not having more of daytime and we're not having too much nighttime. It's equal, and that's why I like fall. Last but not least is the solstice. This is also known as the longest daylight hours. You can kind of read about that here. I'm going to talk more about that in future lessons, but just the summer solstice, that's when we have our longest daylight hours. This is when it gets dark around like 10:05 p.m. In the northern hemisphere. The winter solstice, this is our shortest day. This is around December 21st. This is when it gets dark around like 4:30, 4:35. And we're going to analyze data to actually see what time it gets dark in the future. And here's another diagram to sort of illustrate what I was just talking about here. Again, notice how the northern axis, if you look here, is pointed towards the sun. So we know that it's summer. If you look in the northern hemisphere, the axis is pointed away, and we know that to be wintertime. So I always look for the axis poles and see, is it pointed towards the sun or is it pointed away from the sun? Like right here is pointing away, up here is pointing away, this one's pointing towards, this one's pointing towards. So in summary, there's 4 seasons: spring, summer, autumn or fall, and winter. Both the Earth's axis, tilted axis, and its revolution cause the season. So because the Earth is tilted and it revolves around the sun, that is why we have the seasons. Students, it's not because the sun is closer to the Earth or the Earth is further away. That actually doesn't cause the season. Now, there are certain points in the Earth's revolution that the Earth is technically closer, but it's not related at all to the seasons. I can't stress enough that distance from the sun is not the reason for the seasons. Well, that's all that I have. Feel free to comment. Feel free to give me a couple pointers of how I can make this video better. This is all news to me. Again, I hope you're doing well. Adios, muchachos.